When you're solving a geometric series problem, the first thing you need to figure out is if your series is finite or infinite, because we have two different formulas. For a finite series, you want to use this formula. If you have an infinite series, and assuming that the absolute value of your common ratio is less than 1, meaning your R value can be between -1 and 1, you can use the formula where you have the first term divided by 1 minus the common ratio. If you're not familiar with summations, make sure you see my summation video. But the first thing we want to do for number 1 is decide if it's finite or infinite, and it is going to be finite because there's a number up here. So that means we plug in 1 for n all the way up until 7 for n, and that series stops. I'm going to copy down the general formula for a finite series. The first term is always found by plugging in the bottom number. 2 to the 1 minus 1, we plug that in for n. That's 2 to the 0, which anything to the 0 is 1. And then the common ratio is whatever number is taken to an exponent. So in that case, it's that 2. It's like an exponential equation, a times b to the x. That growth or decay factor is b, the base of the exponent. And then n is the number of terms. So if we plugged 1 in for n all the way up until 7 for n, there's 7 total terms. And remember, the way you can find n is if you're starting with a 1 at the bottom, it's always going to be that top number. And if you're not starting with a 1 at the bottom, you can always do the top number minus the bottom number plus 1. Now we can plug everything into that equation, and we can simplify from there. 1 times anything is itself. Now we have 1 minus 2 to the 7th is 128, over 1 minus 2 is -1. Notice the next problem is an infinite series because there's no final number that we plug in for n. It just keeps going on infinitely. So we can use this formula. Notice there's no n in this formula because there's no total number of terms because it keeps going. A sub 1 is always by plugging in this bottom number for n, so we get 4. R is that growth or decay factor, the base of the exponent, so that's 0.6. Now we can plug both of those in. The sum equals a sub 1, 4 over 1 minus 0.6, and when you plug that in, you'll get 10. So even though you're adding up an infinite number of terms here, the number keeps getting closer and closer and closer to 10. We say it converges to 10. One other problem I want to look at, we're not going to solve the whole thing, but a sub 1 is going to be found normally just by plugging in the bottom number for n. But r, the common ratio, is a little bit harder to see when it's in a form like this. So we could rewrite that 3 over 10 to the n. We can take out the 3 and leave it as 1 over 10 to the n. And now we can write the 1/10. We can take the n on the outside. Because if we were to work backwards, if we put the n back in the parentheses, 1 to the n is just 1. And 10 to the n, we have 10 to the n. But now that it's in that form, when you solve it, we can see that r, the base of the exponent, is a 1/10.